All right, welcome back. So, I've seen a lot of you guys start your homework. That's fantastic. Let me know if you're having trouble. Usually, in the before time when we had classes in person, it was a lot easier for me to walk around as you guys were working and just have you pull me aside and say, "Hey, I'm stuck here." So I'm not a good, my online experience is limited to last semester and now, so I'm not the best at the online stuff. But in person, it's a little bit easier because you can just grab me and ask for a question. So don't feel like I know the median is different, and now it's an email of, "Hey, could you help me with?" I mean, it might take me a little bit because I like to do the videos like this to show you, but I post them for everybody, and I don't reveal who you are. I always just say, "Well, some people asked," and that way you're not outed. I won't say, "Well, Steve asked." Like, who's Steve? Who cares? So we're just working on, you know, I I want you to feel comfortable asking. I'm not going to turn you away. I'm not going to make fun of you. I'm not going to say anything to you to belittle you. Just ask the question if you're stuck. All right. So I'm going to go ahead and share my screen so that we can get started with some unit conversions today. So we'll go through and do that. All right. And quite honestly, the one thing I'm happiest about with unit conversions is I learned how to do this in 1984, and our teacher introduced it as the TIE fighter method. And that's just how I learned it. TIE fighters were from Star Wars, right? The people who watch the movies, you guys know that. And I always called it the TIE fighter method. And quite honestly, throughout 2000 and ever since like 1995 to about 2010, like nobody even knows what Star Wars is. Like TIE fighters, what is that? So when I show you, we'll go with this. All right. The other thing is that we don't live in a civilized country for several reasons. One of them today is January 6th. And if you live in America, if you live anywhere on this planet, you probably know what happened. I recognize that made it incredibly difficult to concentrate today because we're all sitting here watching the drama unfold in our capital. But the other reason is that we don't use the metric system and we have this mess to deal with. So what I would recommend is, at the very least, you might want to print this out when you're doing your quizzes or your final, because I would always print a sheet for this stuff on quizzes and finals for my class, and it would just come with the test. So I think this resource is absolutely something that you should be provided. If we need to make one up, I can do that. That way you guys can have it as a Word document. But I'm going to do is pretty much copy and paste it from here, but it might help it to have it all in one spot. But you are not required to know that there are 16 and a half feet in a rod. All right, that's not what we're doing here. Time, usually I expect you guys to know time. Like I wouldn't write down like, hey, 60 seconds is a minute. I think you guys know that, but they give it to you, so why am I holding it? So, but this is a resource you should have. All right. So what we're going to do here is we're just going to convert. Okay, we're just going to convert and see like how many things are what. So I'm just going to start and at random here, right? How about all right? How about we do we have 126 gallons. How many quarts is that? All right, that seems like a reasonable place to start. All right, so let's go ahead and do this. And what was it? It was 126 gallons. We had to figure out how many quarts. Okay, and here's what I mean by the TIE fighter method. Okay, what we're going to do is we're going to write this down because I have to look this up. I know it's 4 quarts to a gallon, but you never know. So what are we doing here? We have 1 gallon is equal to 4 quarts. Okay, so we know that 1 gallon is equal to 4 quarts. All right, so what we're going to do here is we're just going to do 126 gallons. And we're going to make it a fraction, right? And all we're going to do is say that this number divided by 1 is now a fraction. And notice I include the gallon And if I didn't write anything inside of these parentheses, see, looks like a TIE fighter. All right, I used to draw these things out in third grade and stuff, but looks like a TIE fighter. And then we're going to say, well, we know that the 1 gallon is equal to 4 quarts. All right. And I would always screw this up, okay? But here's a way to remember it. These two things are on both sides of the fraction, right? One's on the upstairs, one's on the downstairs. You can cancel these out. If I had messed this up, and I am likely to do so, okay? We have 126 gallon. If I had wrote this backwards, these don't cancel. All right, the gallons do not cancel. I ended up with gallons squared over quarts or whatever unit that weird thing would be. Okay, so if you can cancel the gallons out because they're one's on the up part of the fraction, the other one's in the denominator of the fraction, then you know you got this in the right direction. Okay, that's one way to double check yourself, and that's a very powerful thing to deal with. All right, and then we have our I don't have a calculator. What did I not do? Oh no. Okay, hold on here. TI, I wonder if I can do TI this way. All right, it's in my documents file, I think. All right. No, I don't want that. Okay, hold on a second here. It's going to be in my documents. And you see all the stuff, how messy this is, right? There we go. Okay, virtual calculator. There we go. We're set. I got to clean this thing out before the spring semester starts. Otherwise, I'm going to have a lot more things than that. All right. So you have 126 times 4 equals, and we ended up with 504 quarts here. Okay, that's how we do that, right? And that we're going to spend all of our time on today is doing stuff like this. Some of them will get a little bit more complicated, but for the most part, this is it. Let me warn you that I tried to do some of your homework. I did a lot of it, but there were times I frequently got it wrong because the decimal places were wrong. Okay, I didn't put in the correct number of significant figures because it just said use the appropriate amount. I was like, it almost looked like 2 was almost always the appropriate amount until I found a few that weren't, and it was a little frustrating to deal with that. So I want you to know that I'm not going to go through and, like, if you make a mistake on that for your homework, like that's on you, and you've got to fix that because you have unlimited attempts. But I look through your quizzes and your final. I look through it with a human eye. So if I see that that's the mistake, I'm going to give you most of your credit back for that. All right, I might take off a little bit, but that's not something you should not be getting the whole problem wrong, like the book will, like the computer will grade you as, just because you missed a decimal place. All right, so if that's the mistake, I'm giving you points back for that. All right, so I don't want you to worry too much about, I missed part of the decimal place. That's not a mistake that should cost you, a huge amount. So realize that I'm going to go through and look at that. Okay. Let's try one that's a little bit more complicated, right? This is 2,500 feet per minute. We're going to change that into inches per second. Okay. So we've got 2,500 feet per minute, and we're going to go to inches per second. So let's just go ahead and write that down. All right, so we've got 2,500 feet per minute. See, this one starts as a fraction. We don't have to do anything. And what's our goal? Our goal is inches per second, okay? So when I'm done with all of this, all of the units cancel out, and I should be left with inches and seconds, in inches being on the top and seconds being on the bottom. So let's deal with feet to inches first, okay? So how many inches are in a foot, or how many feet are in an inch? Okay, I know it's 1 foot per 12 inches, right? So these feet, foot and feet, they're going to cancel. Okay, if I wrote it upside down, then they wouldn't cancel, and I know I'd have to fix that and write it in the correct way. So we'd have a foot and the foot cancel. And right now we got 2,500 times 12 feet per minute. All right, that's where we are. We're going to go one step further. All right, so you got my TIE fighter. And we're going to go from minutes to seconds. So we're going to say, well, I know it's 1 minute. Again, I want these to cancel, so I'm going to write this one on the top to 60 seconds. All right, so the minutes are going to cancel. And then look what I have at the end here, right? We've got inches, we've got seconds, and that's what our goal was. We wanted inches per second, right? Now we have to go through the calculator and get a little bit more out of this. So what this is going to be, it's going to be 2,500 times 12, right? And then our key down here is going to be 60. So if I want to put this in the fraction in the calculator here, right, we're going to do 2,500 times 12 divided by 60. Okay, now you don't need these parentheses on this particular problem, but if there was another problem where we might have more stuff on the bottom, I would want to put all the stuff on the bottom together, and that's how I'm going to group it together with parentheses. So it's the stuff on the top times together, divide, and it would be all the stuff on the bottom times together. We'll do one that's going to do that for us, okay, in a little bit. But I want you to see what's going on here as far as like how do I get this thing put in my calculator, right? So we've got 2,500, right, times 12 divided by 60. All right, so this is 500 inches per second, right? So if you have 2,500 feet per minute, right, that's 500 inches per second. I'm sure you're glad to know that now. All right, so that's where we are. Okay, let's try another one. Okay, let's see. This still goes to pounds. They have quite a few. This is why there's like a ton of problems in your book for this one. This is there's a lot of problems, and they just are getting used to doing this. Okay, why don't we try 8.00? See, there's two significant figures on this one. 8.00. What the heck is a BU? Is that a bushel? I don't know. Volume. What are they saying? This is one. They don't even tell us what it is. I think it's a bushel. Okay, I think that's a bushel. But we're going to know, right, that we're going to come back to that problem, and we're going to say that 1 BU is equal to 2150.42 cubic inches. Okay, so let's see what we have going on here. So that's I think it was just the next page, right? Where are we? Down here somewhere. There we go, 25. So we just want to go from bushels to cubic inches. Well, that's convenient. It's almost like they made this for this problem, right? So we have 8.00 BU equals how many cubic inches? Okay, so we have 8.00 divided by 1 BU. Okay, here's my TIE fighter. And then what we're going to do is we have to put the BU on the bottom, right? 1 BU down here. And we're going to say there's 2150.42. This one is in your book. I know because I got this one wrong because I gave it the wrong significant figures. Okay, so all we're going to do here, right, is just say 8 times 2150.42 equals. Oh, I know I got this one wrong. It's because I didn't carry out all my decimal places. So this was 8 times 2150.42. Okay, so we have 17203.36. Now, if you type this in the computer, you're going to be wrong. because we have 1, 2, 3 significant figures. Okay, these little conversion factors, no matter how many, one of the, I'm old enough to remember they have little public announcement cartoons for trying to get the United States to move to the metric system. This was in the 70s. And one of the things they would do with their commercials is that they would take these conversion factors and they would just round this all the way out. There'd be like 27 digits to it. They're like, you have to remember all of this. Like, no, you don't. But we're only going to go 1, 2, 3. Okay, so this answer is going to be 172, and we're just going to drop all of that. All right, so that's how we're going to do that as cubic inches. Okay, so be careful about that. The book is very picky about you doing that, but when you're taking your quiz and you're taking your final, I'll still dock you a little bit for that. So you don't want to make a habit. You do want to make a habit of getting a little bit better about this, but at the same time, I'm not going to dock you a whole question's worth of points over this because that's insane. That's too much. All right. So we're not playing that. All right. Let's see. I think we're okay. I don't know if I should do another one. I'm going to tell you what. We're going to move on to the next little part here. Actually, you know what we're going to do? We're going to do one of these problems. Hydrology. I took hydrology once. That was a fun class. So yeah, we're going to go ahead and do a hydrology problem and then see what's going on here. Okay. So it says a reservoir has a capacity of 9,000 cubic feet. How long will it take the reservoir to fill at a rate of 250 gallons per minute? See, this is a nice problem. I like this kind of stuff because it forces you, it has several moving parts to it. Okay, but let's see how we can figure this out. Okay, we have 9,000 cubic feet. Okay, so my reservoir is equal to 9,000 cubic feet. Okay, forgive my heater. That's just where we live. Okay, and we're gonna fill this thing at 250 gallons per minute. Okay, so we're going to go with 250 gallons per minute. Okay, and what are they asking? They want to know how long is this going to take, right? How long will it take to do this? How long? Okay. So what I think we should do is, I can't just multiply or divide these things. So they got cubic feet and I got gallons. Minutes I eventually want to be at the top of the fraction. So I kind of have an idea of how I want to set this up, but I gotta convert this, right? Either this cubic feet has to go to gallons, or this gallons has got to go to cubic feet. Okay, I'm a little bit happier with gallons because I buy gallons of milk and I understand that one. I buy gallons of gas, I understand it. Cubic feet, I'm like, I don't really know what that measurement is. So let's go ahead and take our cubic feet and figure out how many gallons that is. All right, so we're going to take 9,000 cubic feet, divide my little TIE Fighter weights on here, and what are we going to want to have happen, right? We want whatever the cubic feet is going to be on the bottom here, and the gallons we want to have on the top. So my apologies, I got to look this up because I don't have this off the top of my head. All right. So we're going to have to go back 2 pages here. Okay. We're going to look at our volume measurement and we're going to say what about our thing? We're going to say cubic foot is equal to 7.48 gallons. Okay. So a cubic foot is equal to 7.48 gallons. So just off to the side here, we're going to do 1 cubic foot equals 7.48, 7.5 gallons. All right, so we have 7.48 gallons, right, to 1 cubic foot. So now the cubic feet are going to cancel, right? So it's got gallons here. And then it's asking me how long this is going to take. So we know that we have an additional equivalence here. We have 250 gallons every minute, right? That's the rate of flow. So the gallons are going to cancel, and I'm going to just be left with time here, okay? So our problem is going to look like this, right? We sorted out our units, right? We only have this little one left here, right? We pick with this one, right? Everything else canceled out. We just have our minutes left. That's a time. That's how long, right? So we're going to say this is 9,000 times 7.48 divided by 250. Right? All the stuff on the bottom goes after the dividing sign. Stuff on the top goes before the dividing line. And then we're just going to write that down. Okay, we've got 9,000 times 7.48 divided by 250. And it's going to say, well, we got 269 point what? 0.28 minutes. I have a feeling if you told somebody it's going to take 269.28 minutes that they're going to yell at you. So why don't we do this? Why don't we say we have 269.28 minutes, right? And how about we call that, we say that there's 60 minutes in 1 hour. Again, check to make sure your units disappear the way they want to. So we just have hours now, and we'll just go ahead and do that. So we'll have 269.28, right? This will be 269.28 divided by 60. So 269 divided by 60 to get the hour, and 4.448. Again, I think somebody will get upset. We'll just call it 4.5 hours. Okay. All right. But if the computer told you, go to the thousandth decimal place or whatever, we'll go all the way out here. That's fine. Whatever it tells you to do, that's what we'll try to do. All right. But since it doesn't say anything, it didn't say anything. I still don't remember it saying anything. We're just going to go with that. All right. So let's see here. Do we want to do another one of these? How good do you feel about this? All right. I think the one in your books are a little bit easier than all of these, so we'll probably go ahead and oh, there we go. This is I always like the culinary arts ones because I think people have a better idea about cooking, and it's easier. It's more relatable than a lot of this other stuff. I mean, nobody deals with hydrology is not a normal thing. Okay, so let's go. We have a recipe for gazpacho soup. It calls for 2 tablespoons of lemon juice and a half cup of olive oil. Actually, I think I've asked this one on a test before. So it says the given recipe serves 4 people, but a cook wants to make a larger batch that serves 40. Okay, so again, there's a lot of moving parts going on here. Okay, so let's figure out what we're doing with this. Normally it serves 4 people. And we got to scale this up to get to 40 people. This is effectively the last chapter, right? Is what scaling factor would I need to go from 4 to 40? I think you could do this one by inspection and say, well, if I multiply everything by 10, that's the appropriate scaling factor. Okay, so I don't need 2 tablespoons of lemon juice. We need 2 tablespoons, right, times 10, because we're making this for 10 times the number of people. Okay, I know not ingredients scale this way, but it's a math book, and that's what they're just going to assume. Okay, so we've got 20 tablespoons of what was it, lemon juice. All right, and we have half a cup of olive oil, right? We have 0.5 cups times 10, right? 0.5 times 10, that's going to give me 5 cups of olive oil. All right. And then they ask us to convert, right? They say, well, how many cups of lemon juice? So we want to go to cups, right? And then what do they want to know about the olive oil? They want to know how many pints of olive oil. Okay. So what we want to do is we want to convert 20 tablespoons into cups. All right. We're going to need to look up that recipe or that first table again because I don't know how to go from tablespoons to cups. If you do, you're a much better cook than I ever will be. Okay, but our goal here is to go to cups. All right. Teaching this a couple of years ago and making up my own systems here, just having people go all over the place with it. But we don't have time for that in this class. We're not going to do that. Okay. So liquid capacity here, right? Here's our tablespoon, and we're going to go from tablespoons to fluid ounces. So 1 fluid ounce is equal to 2 tablespoons. So we'll go ahead and write that down. Okay. So off to the side here. Wish I had a side. Here we go. All right, we're going to go off and make a little note here. We're going to say 1 fluid ounce equals 2 tablespoons. All right, we're going to say that, oh, we have a measuring cup for 8 fluid ounces, right? 1 cup equals 8 fluid ounces. And they wanted us to deal with cups. All right, so if I can go from tablespoons to fluid ounces and fluid ounces to cups, I'm going to be okay. All right, so we have 20 tablespoons, and we're going to say we have, how do I get this to cancel, right? Where do I put the tablespoons to make this cancel? It's going to be 2 tablespoons down here. We have 1 fluid ounce. All right, and then we're going to say we have 8 fluid ounces to 1 cup. And again, the fluid ounces, that's going to cancel. The tablespoons, that's going to cancel. And we're just left with the cup. That's what they wanted us to do. So here we have, okay, we have 20. That's all the stuff on the top, right? I mean, you could type in times 1 times 1 if you wanted to. It's not going to hurt nothing. But divided by, and we're going to pick all the stuff on the bottom. It's 1, right? But 2 times 8 down here. Okay, now you're going to need those parentheses. Okay, so we have 20 divided by 2 times 8. Okay, or 20 divided by 16. Okay, so we have 20 divided by parentheses 2 times 8. You need those parentheses. Okay, if you don't have them in there, it's going to say, well, I'll show you. It'll say 20 over 2, which will be 10. 10 times 8 is 80. Okay, but we have 1.25. Okay, that kind of makes sense. I know what a tablespoon is. I know what a cup is. Saying that 20 tablespoons is going to be 1.125 cups is probably okay with me. Okay, but if you do it the other way, if you just say 20 over 2 times 8, right, what's it going to give us? It's going to say 10 times 8 is going to be 80. So you have to be real careful with that. Okay, and then we're going to go from cups into pints. Okay, we're going to go from cups into pints. So we know that 1 pint is equal to 2 cups. Okay, so we have, what do we have here? We have 1 pint is equal to 2 cups. And they just wanted us to do a one and done sort of a calculation here. So we have 5 cups, make a little fraction, put my TIE Fighter wings. All right, and we have 2 cups down here to 1 pint. And the cups cancel. Right, we have 5 divided by 2, that's 2.5. Right, so we have 2.5 pints that we're going to work here. Right, 5 divided by 2. There you go. So that's, I like these problems because you have to scale them and then you have to do the unit conversion, and I just think that's kind of neat. But the other thing that I really like about this is it's food. It's just scaling up a recipe. It's a really graspable kind of concept. All right, let's look at the next chapter part here. Okay. Now I don't exactly agree with teaching this particular setup for you guys because it's going to the metric system. Now, I love the metric system. That's not what I'm talking about. But a lot of the training you get in, oh, we can talk about that too. Okay. A lot of the training you get in the sciences, especially the early sciences. So if you're going into sciences, or if you're going into a trade that uses a lot of science units, you have to have an idea of what things are. And that's the first thing that they're going to ask you is, what is it approximately? Okay. So they don't want you to actually calculate stuff. We will, okay, but they want you to kind of get an idea of what things are so that you can use these units, or at least you can think about them in a way that is a useful thing. So if I say, well, mark off about a foot, every one of you could estimate a foot and mark that off. If I say mark off about a meter, and like very few of you are going to look at that and say, well, that's about 3 feet long. Okay, it's a little bit more. I always have my good story for a meter versus a yard. And if you're old and you went to Catholic school, you'll know which one is longer. Because the meter stick, if you were sitting in the second row and you gave sister, back talk, she'd smack you with one of these. And if you have a good day, then it would be a yardstick, and you could duck, you could dodge it, you could lean back, and she would not hit you with it. But if it was a meter stick and you lean back, you're going to catch the corner on your nose or on your forehead or something, and it's going to hurt. She didn't mean to do that. They always tell you that, right? I didn't mean to hit you the corner. If you didn't move, I just would have hit you with the flat part. It wouldn't have bothered you. It wouldn't have hurt that much. So it's your fault that I hit you with the corner of the stick, not mine for swinging it. It's your fault. So you sit there and take it. So you gotta love the rationales of people who dish out punishment that way. So yeah, if you're a Catholic school kid, a meter is a little bit longer than a yard. If you're a swimmer, a meter is a little bit longer than a yard too, because most of the pools in America we use yards. And then they say, well, you swim meters now. Oh no. Each one of those it's only 3 inches per one, but when you're talking about 1,000 yards or 1,000 meters, like that's a lot of distance. So that, and I know a couple others. I know kilograms versus pounds. I know I read your intros for a lot of you, and you do. A lot of you are into fitness. So if I handed you a 24 kilogram kettlebell and I said, here, this is what we're going to work with today, the fitness people are going to say, well, it's going to be kind of a rough workout because I know that 24 kilograms, it's like times 2, right? It's times 2.2, but it was times 2. So that's 48, and it's 10% more. So, so what is that? That's 48 plus 4 is going to be 52.8. It's about 53 pounds. Okay. So that's really how people should think about this stuff. But to be fair, they spend a lot of time in science classes, at least they used to, especially labs, kind of getting you accustomed to thinking this way. And that way it's a little bit easier when you have to do stuff like this. Because they want you to think about that. They want you to say, well, what is 500 grams? Well, 500 grams is about a pound or so. It's a little bit more, but that's all right. 1 gram is about a paperclip. Okay, that's a very standard sort of a conversion. If you ever have to take temperatures, right, to go from Celsius to Fahrenheit, there's a formula, right? It's 9/5 C plus 32. Like, don't. If you have to do a test and you have to write down the actually right answer, then go ahead and do this. Right, this is your Fahrenheit. If if you're on vacation and you're in a country that only uses metric and they tell you it's 10 centimeters, well, don't do this. 9/5 is really close to 10/5, right? And 10/5 is a fancy way to say 2. So we're just going to say, now don't estimate like this on an exam. All right, they want the actual number. They don't want your approximation. But if the TV says it's going to be 10 degrees Celsius today, then I'm going to say, well, double it and add 30, And I know that that's going to be about 50 degrees out, and I'm going to need a coat. I'm going to need, not a winter coat, but I'm going to need something because that's a little chilly to be walking around without a coat. Okay. Or if somebody says, hey, it's, F was there, the temperature was 30 degrees today, right? You might be listening to somebody from Australia talk like that. So it's 30 degrees. You're like, 30 degrees, that's freezing. Like, nowadays Celsius. It's 90 degrees for them today. That's pretty warm. So there's little approximations you can get to do this where you don't need the exact number. Like somebody says it's 30 degrees out, like don't wear a jacket. All right, wear shorts. If somebody says it's 10 degrees, then wear a jacket. But you don't need you don't need 10 degrees Fahrenheit jacket. You need fall weather jacket. Okay. So they have us do that a lot. I'll show you what the problems look like. I'm not very good at knowing what electricity is offhand. Yeah, so these are the kinds of problems they give you is like, what's the diameter of a penny, right? So you have to know that a penny, it's about 2.5 centimeters to an inch, right? So it's 2.5 centimeters makes about 1 inch. And what a penny is, right? Is penny is not an inch long, right? It's less than that. So I'm looking at either 3 centimeters or 1.5. I would go with 3. It looks like about a ½ inch. That might even be too much, right? If it's a 1/4 inch, there we have that. All right. Length of a man's foot. Well, it's not 3 meters. That's 18 feet. Okay. It's almost a yard. So just to approximate, like your foot is not that. 3 centimeters, way too small for 3 centimeters. Okay, 3 centimeters is, we looked at that as a penny. 30 centimeters, well, that's the one that's left. So I'm going to guess it's about that. Okay, again, I know 2.5 centimeters to a foot, 5 centimeters is 2 inches. So 5 times 6 is 30. So 2 inches times 6. Yeah, that seems about right for a foot. Okay. So they ask you a lot of these kinds of questions. You also find out how easy it is to convert in metric, and then you will curse the people that kept us in the dark ages of using imperial units. Yeah, imperial units for this long, rather than letting us do metric. Okay, so yeah, it's 27 kilometers. How many is that in meters? Well, the K means 1,000, so this is 27,000 meters. Okay, that's what you do. There's 1,000 milliliters in a liter, so 0.2 liters per kilogram. Oh, this changed 2 things. I'd have to work this one out. Okay. Yeah, let's do that. I'm pretty sure I know what that is, but yeah, let's just be careful, because if you don't know, right, I don't want you to guess. I want you to be able to have a way of working it out. So how do we convert 0.2 liters per kilogram to how many milliliters per gram? All right, and it's not be prepared to be surprised. Okay, so we have sometimes this doesn't work out so well for us. So we have 0.2, what is this, liters per kilogram, and we want to convert to milliliters per gram or something. That's what we wanted to do. Yeah, 0.2 liters per kilogram. We wanted to go to milliliters per gram. Okay. So we have 0.2 liters per kilogram. Okay. Still going to use the same tools here. All right. How many milliliters are in a liter? It's 1,000. Okay, we have 1 liter. We have 1,000 milliliters. Okay. And then kilograms. How many kilograms? Right? How many grams are in a kilogram? That was also 1,000 grams are in a kilogram. So still, see, we cancel the units. And now we're left with milliliters per gram. And what happens to these thousands? Right? Do I need to put that in the calculator, or can you see that these are going to cancel and we're still going to get 0.2 milliliters per gram? See, I told you to be surprised. All right. So that if you don't know that, and that's okay, right? That's what we're doing here. We're learning, and you're not familiar with these units. No, you know, we live in the States. We don't know. So, you know, it's okay to work it out. All right. There. Now we know. Okay. So if somebody asks me tomorrow about liters per kilogram and milliliters per gram, I'd say, oh, you can't fool me. I got this one last night. Okay. They ask me in 6 months, I'm going to say, I'm going to have to work this out. I don't know. All right. So, but I don't think they asked you any of these harder questions for this. I think it's mostly this stuff in here. Okay. So that's what we have. Okay. Let me indulge me for a moment. We'll take care of 5.3 tomorrow. Okay. So just indulge me for this last little bit. Not part of the class, just part of something that's nice to know. Kilo, right? That's times 1,000. Mega, that's times 1,000,000. What do we have on computer? We have giga, that's times 1,000,000. Here's a billion. Okay. And what do we have next? We have trillion. So we have kilo. It's times 10 to the 9th. This is times 10 to the 12th. I think we have tetra, which is times 1,000,000. Okay. So back in the days of your parents or maybe grandparents, we had kilobytes. Okay. So this was, if you remember what a kilobyte disk drive was, okay, or when we measured files in kilobytes, you can even see it on files today. They say KB on them. So it's kilobytes. It's if this is 1 times 10 to the 1, 2, 3. Okay. Mega, we have 1, 2, 3, 4, 5, 6. Right. We have megabyte drives. Right. We have kilobytes. Right. We have megabytes. Right. We have files that are megabyte. Right. If you look at your music files, it's probably in the megabyte type of time. But we used to have whole hard drives that were megabytes, and I would say, "Wow, how could you ever fill that up?" See, that's how old I am. Right? Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 1 times 10 to the 9. This is gigabytes. All right, that's like my hard drive is a gigabyte, or it's several gigabytes large, right? And again, it's like, how the heck can I fill that up? But yet we have. Okay, and then here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, we have 1 times 10 to the 12th, and that's a terabyte, right? So some of you might have terabyte hard drives, or at least maybe you're eyeing on buying one soon. So that's what we have. But here's also what we can do, right? The kilo, this is when somebody says $1,000, right? You can think about that as a kilodollar. But when somebody says $1 million, right? That's 1 times 10 to the 6. So a million, if that is 1,000, 1 times 10 to the 3, 1 times 10 to the 6. Okay. Giga, that's billion. Okay, in the US system. The English actually is a different system, which is a little bit more complicated, where billion is a bit bigger of a number. But since American banks are predominant, we use the American system mostly. Most of the world uses the American system. But that's 1 times 10 to the 9. There are, right? How do I get from here to here? There are a million thousands in a billion. Okay. So there are 1,000 millions, right, in $1 billion. So there's one, if you wanted to say, I'd like to make 1,000 people real happy and give them $1 million, you would spend $1 billion to do that. Okay. And then we have trillion. Right? Just 1 times 10 to the 12th. Okay. And I really wish this was a little bit more. I wish people use this a little bit more in the news when they talk about money, because you say million, billion, and trillion, and this happens to me too. I mean, people's eyes glaze over. They don't know the differences between these numbers, right? There's 1,000 million in a billion. There's 1,000 billion in a trillion. There's a million in a trillion. Okay. So just using numbers that look like this, I know it's intimidating at first, But if you're talking to somebody about a budget, and about money, and you really care, I would rather see the numbers laid out like this so I could figure out what size they are, because people use million and trillion in the same sentence. And if you got you're talking about $1 trillion, and like, oh, but that cost a million. That's way too much. Like, if you're a millionaire, are you worried about the penny that you dropped? Like, no, that's the difference here. So it's started with computers because people are familiar with their computer sizes, or at least their file sizes a little bit. And then we can convert that to money. And then we could talk about how sizes are. So when you hear people swinging around words like a billion and a trillion, and then they get concerned about millions, like, dude, you're way out of your league. This is billions and trillions, and then millions is like way down here. This is pennies compared to this stuff. So if people are okay with spending billions and trillions, right? I mean, you need 1,000 of these millions in order to make that up. So it does add up. But if people are really concerned about millions, you don't utter these numbers, right? Because if you're worried about this should scare the heck out of you. Okay, so don't. When people try to say all these words, million, billion, and trillion, realize that there's different sizes of these things, and how much bigger one is compared to the other. And I will usually, if I really care about it, I'll write them down so that I can keep track of it, because it's too easy. These words are not words you use on a daily basis and compare. Okay, so that's your number sense, number literacy for the day. We'll get a jump on 5.3 tomorrow. If you get there before me and have questions and get stuck, please let me know. I would love to make more of these videos for us. If I make little small ones that are 12 minutes long, kind of a thing, that makes it easier on everybody. So I want to answer your questions for this, so let me know. All right, we're gonna stop, and we'll go. If I had other people in the chat today, I don't. You can see participants one. This would be a good spot for you to say, "Hey, I got some questions." All right, because I can stop the recording, and then we could do that. So speaking of stopping the recording, you guys go do your homework. It's all good, and let me know if I can help you.